Good morning to all of you. Finally, we have come with the first chapter, or you can say the first step to our quest to know this universe. And in this first step, or in this chapter, or in this lecture, we'll try to figure out the building blocks of this universe. What are the fundamental blocks from which this universe is made up of, and till date, what we have reached? That's a very important question. Is so it's always a billion-dollar question that what are actually the building blocks of the universe? People were always wondering. So first ever logical theory came into Greek mythology. They spoke about four things. The first one is fire, earth, water, and wind. So these are the four fundamental blocks of everything what you have seen till date. You are made up of these four fundamental things. I am made up of these four fundamental things. This camera is made up of all these four fundamental things. And everything till date what you have observed is made up of these four fundamental things. Similarly, in Indian mythology, they have given one more element that is called space. So we finally come with the five things that we call the Panch Tattva. Chiti Jala Pavaka Gagana Samira, that is fire, earth, water, space, and wind. So these are the five things they have created everything. Everything till date what you have observed is made up of these five things. But as the science progressed, people don't find this theory very logical. And then a man come into the picture named Democritus. Democritus proposed the word atom. Atom is something smallest. Atom means smallest. And then we have came with one first atomic theory that given by Dalton. So Dalton said, suppose you are having a piece of substance, and if you start subdividing it, then at a particular point you have to stop. You cannot go further, and that stopping point will be atom, the smallest unit. So in Dalton's concept, atoms are absolutely indivisible. So every element, doesn't matter whatever element you pick, and if you start subdividing it, you have to stop at one point, and that point will be atom. So that's why in all the Dalton's formula, atoms are always taken in the whole number because atoms are indivisible. Then one more man come to the picture named J.J. Thomson. Thomson discovered electron. So he actually discovered a substructure inside the atom, and that was the death blow to the Dalton's atomic theory, because he proved that there is something exists smaller than the atom, and we can take it out from the atom. And that was the electron. So then Thomson gave the first atomic model. In that model, he proposed that there is a positive base, solid positive base, over which the negative charges are embedded. And he named that model a plum pudding model. A pudding is a dessert and plum is a berry. So that dessert constitute the base, and then plums, the berries, are actually embedded, and these berries are negatively charged particles. In other concept, you can make a similar example like a watermelon. Suppose you slash the watermelon, then the red base is actually the positive charge, and those black seeds are the negatively charged electron. So that theory given by J.J. Thomson. Similarly, simultaneously, at that time, two students of Rutherford, Geiger and Marsden, performed an experiment called the gold foil experiment. Actually, they have taken different kind of metal sheets or metal foils actually, and they bombarded the alpha particle on that, and they just draw some experimental data. The most successful was the gold foil experiment. In that experiment, they observed that most of the alpha particles passed away the gold foil without getting deflected, and some get deflected through large angles, and 1 out of 10,000 or 8,000 get rebound back. And when Rutherford had seen those results, he finally came up with a theory called the Rutherford atomic model. And in that model, is said that most of the part of the atom is hollow, because most of the alpha particle actually crossed it without getting deflected, and all the positive charge and all the mass almost gets concentrated at the center, termed as nucleus, because out of 8,000, one get rebound back. That actually hits the. It actually not hits, actually going towards the nucleus, it gets rebound due to the positive repulsion. So that was the Rutherford's atomic model. In that model, actually, if I can simplify it, there is a positive charged nucleus contain almost all the mass of the atom, and then there are negatively charged electrons orbiting that positive nucleus. So in circular orbits. So that's what we call the Rutherford atomic model. So we are having two models simultaneously that time. Thomson's atomic model and Rutherford atomic model. Both models are having their own pluses and own minuses. I'm not going into details, but they're having their own pluses and minuses. Like the biggest drawback with the Thomson atomic model, it is not able to explain that Geiger-Masterton experiment Second is it is not able to explain those hydrogen spectrum. Similarly, in Rutherford experiment, the biggest problem is the question of say stability of the atom, because we know from the principle of electrodynamics, whenever a charged particle accelerates, it actually loses energy. So whenever electron is orbiting, it should release energy, and so that its orbit will get shorter and shorter and finally get fell down into the nucleus. Actually, and if electron falls inside the nucleus, then atom is over. So then if atom is over, nothing will exist. So it's really make a question mark on both models. So then one more man come into the picture named Niels Bohr. So Bohr said, okay, I will study 6 months Thomson, 6 months Rutherford, and then I will come with a new atomic model. So actually, I hope 6 months he had studied Thomson and 5 months Rutherford, and then he come with his Bohr's atomic model based upon certain postulates. Postulates are scientific assumptions which needs not to be proved. The first assumption was that electrons are not allowed to move in all orbits. They can only move in those orbits for which the value of angular momentum is quantized. I'm sorry that for non-physics background people, angular momentum may be a typical term. I will explain it later. So the first concept was that electrons are not allowed to move in all orbits. They can only move into certain orbits. Just like that, you're driving a car on a multi-lane road. You are not allowed to go in all the lanes. You are only allowed to go in certain lanes, or a one lane or two lane, which are permissible. The second concept was that while moving in a particular orbit, electron would not lose energy. So actually it fixes the problem of stability of the atom. And third was, whenever electron jumps from a higher energy orbit to a lower energy orbit, or lower energy orbit to a higher energy orbit, it either absorbs energy or releases energy, but only in integral multiplication of that energy packet called quanta or photon. Now, here you have to understand something that Mr. Usually student used to do that. Suppose this is a 5 joule energy level and this is a 2 joule energy level. So student thinks that whenever electron jumps, it actually jumps like normal anything, like something, you drop something. So suppose that if it is like that, then at any instant of time electron will be here, until it will reach the 2 joule energy. It means electron will be in all the energy levels between 5 to 2 at some instant of time, and it is not possible because Bohr said electron cannot allowed to exist in all energy states. It can only have discrete energy state. Similarly, it is only possible if electron will disappear here and reappear here, disappear here and reappear here. That you have to understand. Similarly, orbits or not some physical state. That doesn't mean that this is orbit number 1, this is orbit number 2. So electron jump from here to here. They are actually not geographical position. They are actually the energy states. Means while sitting in this particular point, if I'm having a 10 joule energy, I'm in a orbit X. If I'm having a 5 joule energy, I'll be in orbit Y. That you have to understand. Now, after that, one more man come into the picture named Sommerfeld, and Sommerfeld actually makes a correction in the Bohr's atomic model. He said actually electrons doesn't move in circular orbit, actually they move in elliptical orbits. And then after that, Allenbuck and Gauss-Smith come into picture. They have proposed the vector atomic model. In that model, first time they have proposed that electrons not only orbit the nucleus, they actually spin. And that spin is not similar to the spin of the top. They are called the intrinsic spin. So the first ever the spin term is introduced is in the vector atomic model given by Allenbuck and the Gauss-Smith. And after that, Gell-Mann and Nishijima come into the picture. They have proposed the quark model. What do you mean by quark model? Is that say up to Sommerfeld model, you are having electrons orbiting outward, and then they are having a proton and neutron inside the nucleus. So we are having 3 fundamental particles: electron, proton, and neutron. But Gell-Mann and Nishijima said actually what you are saying, a proton and neutron, they are not indivisible. They are divisible, and they consist of some smaller blocks called quarks. So they have proposed different kind of quarks. They are basically 3 sets of quarks actually exist on Earth: up quark, down quark, and strange quark.